We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, welcome in lecture of Fluid Mechanics subject. Myself Mitesh Patel. I am an assistant professor in a mechanical department at a Dr. SUBHASH Technical Campus, JUNAGADH. Today's our lecture topic is a types of fluids. So in this lecture we discuss about the types of fluid in details. So let's start the lecture. The fluid are mainly classified into the 5 categories. First one is the ideal fluid, second one is the real fluid, third one is the Newtonian fluid, fourth one is a non-Newtonian fluid, and fifth is a ideal plastic fluid. Okay, now all fluids behavior we can easily study by the shear stress versus shear strain diagram or graph. Here in this figure, all fluids shear stress versus shear strain diagram are combined together in one figure. So we can easily study all types of fluid and differentiate the all fluids and its property. Okay, so let's start the more discussion about this 5 category of fluid. First one is the ideal fluid. A fluid which is incompressible and it's having a no viscosity is known as a ideal fluid. So in short, the fluid having a shear stress is 0. So fluid having a shear stress is 0, so it's not having a viscosity. But in actual, all the fluids having a some kind of viscosities. So in real, it's not possible the fluid having a zero stress or no viscosity. So it is the imaginary fluid. In real is not exist. Okay. So we can draw the graph of this fluid. The shear stress is 0. So its line is perfect horizontal at a 0 point. These are mentioned here. Okay. Now next is the real fluid. The fluid which possesses the viscosity is known as a real fluid. The all fluid in practice are real fluid which having a viscosity. We earlier discussed that the all fluids having a viscosity, the all fluids are a real fluid, and real fluid are fulfill this equation, shear stress is equal to du by dy. So in this graph, all fluid which having a viscosity are a real fluid. Okay. Next is a Newtonian fluid, a real fluid in which the shear stress is directly proportional to the rate of shear strain or velocity gradient is known as a Newtonian fluid. Okay. So Newtonian fluid, in short, we can say that the shear stress is directly proportional to shear strain, then the fluid is Newtonian fluid. And in short, we can say that it's follow the law of viscosity, Newton's law of viscosity, then fluid is a Newtonian fluid. We know that the Newtonian fluids follow this equation, shear stress is equal to du by dy. Okay, sorry, mu du by dy. Now Newtonian fluid is mentioned in this graph, in this line. The line is perfectly straight and inclined as shown in figure, because shear stress is proportional to shear stress directly. So line is straight incline. Okay. The example of Newtonian fluid is a water, air, thin motor oil. Okay. Now non-Newtonian fluid, a real fluid in which the shear stress is not proportional to the rate of shear strain, is known as a non-Newtonian fluid. Okay. The example of toothpaste, solution or slurries of some materials, mud flows, polymer solutions and bloods are the example of non-Newtonian fluid. So this is the line of non-Newtonian fluid in which the shear strain is not directly proportional to shear strain. Then the fluid is a non-Newtonian fluid. The non-Newtonian fluids are generally complex mixture and are studied under the rheology. It's the science of deformation and flow. The non-Newtonian fluids equation is a shear stress is equal to du by dy raised to n. Okay. So if n is equal to 1, then fluid is a Newtonian fluid, but in non-Newtonian fluid, value of n is a less than 1 or greater than 1, not equal to 1. If n is equal to 1, then fluid is a Newtonian fluid. And n is defined the value of slope of line. Okay. So non-Newtonian fluid is further divided into two categories. First one is the pseudo plastic fluid, or other one is a Dylan's fluid. Okay. So pseudo plastic fluid, in case of non-Newtonian fluid, if the value of n is less than the unity, then our fluid called the pseudo plastic fluid. Okay. Example is a paper pulp, rubber and rubber suspensions, paint. Okay. So in this equation, value of n is a less than unity, less than 1. So fluid is a pseudoplastic. So here the n is a nothing but the slope value. So here the slope value is less than 1. So fluid is a pseudoplastic. This line mentioned the pseudoplastic fluid in this graph. Okay. Now Dylan's. In this case of non-Newtonian fluid, value of n is greater than unity, then the fluid is called Dylan's. Okay. And the non-Newtonian fluids obey this equation. Shear stress is equal to du by dy, and the value of n is a greater than 1. Okay. So Dylan's fluids line is shown in this graph, and n is a slope value, it's a greater than 1. Okay. The example of Dylan's is a butter, printer ink. Okay. Now plastic fluid, a fluid in which shear stress is more than the yield value, and then shear stress is proportional or not proportional to the rate of shear strain, is known as a plastic fluid. Okay. In the case of plastic substance which is non-Newtonian fluid and stress is exceed to the yield stress to cause a continuous deformation, these substances are represented by straight line intersecting the vertical axis at a yield stress. Plastic fluid is further divided into the two categories, ideal plastic and thixotropic plastic. In a plastic fluid, firstly, if we apply the shear stress, then nothing happens and fluid is not flow. But if increase the value of shear stress, then the yield value, then and then deformation is occur, means we can say that fluid is flow. then fluid is flow. So when apply the shear stress to the plastic fluid, up to the yield stress, it's not move or flow is created. After, if shear stress value is move after the yield stress, then and then flow is occurs in a plastic fluid. Okay, in ideal plastic fluid has definite yield stress and constant linear relation between the shear stress and shear strain. Okay, the example is a sludge and drilling muds. Okay, it's a ideal plastic fluid. So in ideal plastic fluid, after the yield stress, the fluid is behave like a Newtonian fluid. So graph is, in this graph we see then the line is perfectly straight incline. So shear stress is directly proportional to shear strain after the yield stress. Then the fluid is known as a ideal plastic fluid. Okay. Now thixotropic plastic fluid is fluid which is non-Newtonian fluid, has a non-linear relationship between the shear stress and the rate of angular deformation beyond the initial yield stress. Okay, example is a printer sink. So in this plastic fluid, after the yield stress, the fluid line or fluid having a shear stress is not directly proportional to shear strain, so the graph is not straight. So this type of fluid is a thixotropic plastic fluid. Okay, thank you friends. I hope you very well understands the types of fluid and its difference between them. Okay, thank you again.